Look up at the night sky. What do you see? Stars, maybe a planet. The faint glow of the Milky Way. For all of human history, we've stared into that darkness with wonder, asking, where did we come from? How did it all begin? Today, we have a new tool to help answer those questions. The James Webb Space Telescope, or JWST. JWST is more than a telescope. It's a time machine. Light travels at a finite speed. When you look at the sun, you see it as it was 8 minutes ago. The nearest star, over 4 years ago. Andromeda, 2.5 million years. We are always looking into the past. Webb takes this to the extreme, peering so far that it sees light from over 13.5 billion years ago. This lets us witness cosmic history firsthand, seeing the universe as it was in its infancy. It's like flipping through the universe's baby photos, the first stars igniting, the first galaxies assembling. This isn't science fiction. This is what JWST was built to do. With every image Webb sends back, it's as if the universe is whispering its secrets to us. JWST is our bridge to a past so remote that understanding it means understanding everything that came after, including us. So when we talk about JWST, we're not just talking about pretty pictures. We're talking about a fundamental shift in our ability to probe the cosmos. It's a new chapter in the human story of exploration. The telescope is an extension of our own senses, our curiosity, launched into the void to bring back knowledge. With Webb, we're not just looking up, we're looking back, and maybe looking within. The universe is ready to tell its story. Are we ready to listen? How does Webb perform this time-traveling magic? It's all about seeing a kind of light our eyes can't infrared. As the universe expands, light from the earliest stars and galaxies is stretched, redshifted into the infrared. Webb is built to capture this ancient, stretched-out light. To do this, it must be incredibly cold, minus 370 degrees Fahrenheit, so its own heat doesn't blind its instruments. That's why it sits 1 million miles from Earth, shielded by a 5-layer sunshield the size of a tennis court. Then there's the mirror, 6.5 meters across, made of 18 gold-coated hexagons. Gold is perfect for reflecting infrared, and the mirror's size lets Webb collect faint light from the edge of the observable universe. These three things, infrared vision, extreme cold, and a giant golden mirror, are Webb's superpowers. They make it the most powerful space observatory ever built. Hubble showed us the universe in stunning detail. But Webb sees a hidden universe, the one where the story of everything began. It's a whole new set of eyes on the cosmos. Already it's showing us things we never expected. Webb isn't just a telescope, it's a masterpiece of human ingenuity. It's designed for one profound purpose, to push back the darkness and reveal the cosmic dawn. And it's just getting started. The primary mission of JWST is the quest for cosmic dawn. After the Big Bang, the universe was a dark expanse of hydrogen and helium. No stars, no galaxies. Scientists theorized that the first stars ignited, carving out bubbles in the primordial fog, first light. These stars grouped together, forming the first galaxies. Our models predicted these galaxies would be small, clumpy, and chaotic, like little villages of stars. Finding these baby galaxies was the holy grail for astronomers. Using JWST, astronomers stared at empty patches of sky, letting faint, ancient light accumulate. The goal: capture images of galaxies just a few 100 million years after the Big Bang. This isn't just about finding the oldest thing, it's about testing our entire understanding of how structure forms in the universe. The leading theory, lambda CDM, says small things form first, then merge to create bigger things, hierarchical formation. Studying the first galaxies would be the ultimate test of this model. It could confirm we're on the right track, or reveal the universe had a different plan. No one was prepared for what JWST would find. The first deep-field images from JWST stunned astronomers. Instead of small, clumpy proto-galaxies, they found massive, mature galaxies, behemoths, existing just 500 to 700 million years after the Big Bang. Some had as many stars as the Milky Way today. It's like finding a fully grown adult who's only 2 years old. The universe, according to our models, shouldn't have had time to build such massive structures so quickly. These universe breakers challenged everything we thought we knew. Could it be a data error? Were astronomers misinterpreting the brightness? But as more data came in, the evidence mounted, the universe breakers were real. The early universe was far more efficient at building large galaxies than anyone imagined. This discovery didn't just add a detail to our cosmic story, it forced us to question the entire narrative. The universe was building galaxies on fast forward, or by a mechanism we don't yet understand. Cosmology would never be the same. The existence of these massive early galaxies is a direct challenge to the standard model of galaxy formation. That model says small galaxies form first, merging over billions of years to build the giants we see today. But JWST's discoveries throw a wrench into this picture. To form a galaxy as massive as the Milky Way in just 500 million years, you'd need to convert gas into stars at an astonishing rate. The timeline just doesn't work with known processes. The universe seems to have had a cosmic shortcut. This forces scientists back to the drawing board. Maybe the early universe was more violent and efficient than we thought. Or perhaps our understanding of dark matter and star formation needs a major rewrite. Every part of the model is now under scrutiny. The universe breakers didn't just break a theory, they broke open the field of cosmology. Faced with this puzzle, scientists are exploring radical new ideas. Maybe galaxy formation wasn't always bottom-up, perhaps some galaxies formed directly from enormous clouds of gas, born big. Or maybe the first stars were even more massive and short-lived, exploding as supernovae and creating black holes that seeded rapid galaxy growth. Some even suggest our theories of gravity or dark matter need revision. These are profound questions that go beyond just how galaxies form. The JWST's findings are pushing theorists to think outside the box. New simulations are being run, new models tested. The answer, when we find it, will deepen our understanding of the universe's fundamental forces. Science thrives on stubborn observations that refuse to fit. The universe is inviting us to rewrite the rules. This discovery could also change how we think about the timeline for life in the universe. Heavy elements needed for planets are forged in stars and spread by supernovae. If massive galaxies formed earlier, cosmic enrichment happened sooner. That means the ingredients for planet making were available billions of years earlier than we thought. The window for life to arise may have opened much earlier in cosmic history. JWST can't detect life directly, but it can analyze exoplanet atmospheres for biosignatures. The story of life in the universe might be much older and richer than we imagined. We might be latecomers to a universe long capable of hosting life. The implications are profound. The discovery of massive early galaxies is just the beginning. Next, astronomers will use JWST's spectrographs to measure distances, masses, and chemical compositions of these objects. This will confirm if they're truly universe breakers. Meanwhile, theorists are updating models, running new simulations, and testing new ideas. The interplay between observation and theory is how science progresses. JWST's discoveries will shape the next generation of telescopes and the questions they're built to answer. The adventure is just getting started. We explore because we're curious, driven to understand our place in the cosmos. Discoveries like this remind us the universe is more complex and surprising than we can imagine. We must always be ready to have our ideas overturned by new evidence. The universe doesn't owe us simplicity. Its greatest gift is the mystery itself. So keep looking up and keep asking questions. The cosmic story is still unfolding.